140 William Street, a high-rise office building in the heart of the Melbourne Central Business District. The owners of the building, the AMP Society, wish to refurbish it. The proposed refurbishment will have an effect on aspects of fire safety. This video documents the process by which a major innovation in fire safety has been accepted by building regulatory authorities. It's come about as a result of research conducted by BHP Research, Melbourne Laboratories, on behalf of the building's owners. The occurrence of fire in high-rise office buildings is quite a rare event, especially in developed countries. The record is particularly good in Australia and New Zealand. There have been no deaths in sprinklered office buildings in these countries during the 100 years sprinklers have been in use. 140 William Street is a multi-story building of 41 floors with a braced service core. The proposed refurbishment includes the removal of asbestos-based fire protection material from the beams which support the floor slabs and from the underside of the composite floor slabs. But does this fire protection material need to be replaced? Here, the developers were presented with two options. Option 1, replace the fire protection material as the building regulations clearly state. Option 2, come up with an alternative fire safety plan for the building, a plan that demonstrates its ability to meet the fire safety objectives as stated in the building regulations. After discussions between the regulatory authorities, the project managers, BHP Research, and Lincoln Scott, the engineering consultants, the second option was chosen. The refurbishers would direct their research in order to answer two key questions. First, was it really necessary to apply fire protection to the castellated beams and the floor slabs for the building to be safe? And second, was it really necessary to upgrade the building's current sprinkler system from extra light hazard to ordinary hazard, plus a ceiling sprinkler system, as the regulations required? The test building was constructed at BHP Research, Melbourne Laboratories. It was designed to simulate realistically the structural and architectural design of a section of a typical floor of 140 William Street. The research revolved around a series of 4 tests, which would be supervised and witnessed by representatives of the Victoria building referees, as well as a large number of building regulation and building industry personnel. The purpose of the fire test program was fourfold. 1, to observe the nature, duration, and intensity of fires generated by the contents and enclosure of offices typical of those at 140 William Street. 2, to observe and evaluate the influence of the resulting fires on the unprotected composite slab and the structural steelwork. 3, to observe the effectiveness of the extra light hazard sprinkler system. And 4, to obtain data for use in the risk assessments to be conducted in the building. The open plan and small office area of the building was furnished to resemble a crowded but otherwise normal office environment. The workstations and bookcases were furnished to contain large amounts of combustible material, including books, magazines, and plastic-coated folders. The small office was fitted out as a representative office, with the contents including a desk, bookcase, and chairs. The floor at level 2 in the purpose-built section was loaded with large drums of water, which raised the loads to levels similar to the design loads of the 140 William Street building. The mechanical ventilation system operated normally at the start of each test, but was switched off manually when the smoke detector operated, simulating the way this would operate in the original building. This test took place within the small office. Throughout the test, the door of the office was left fully open. The test was started by igniting papers in a waste paper bin inside the office. The drawers of the desk beside the bin were left open and stacked with papers. A single sprinkler operated about 7 minutes and 10 seconds from first ignition. About 20 seconds later, the fire had clearly been controlled. There was no damage to the building or small office other than the effects of small amounts of smoke and water. During the test, the observers present suffered no discomfort. This test took place within the open plan area. Papers were piled high on the desk, as well as in the waste paper bin in which the fire was started. The fire was initiated midway between the closest sprinkler heads. Five minutes and 40 seconds after ignition, the smoke detector operated. At 6 minutes and 19 seconds, 4 sprinklers opened in rapid succession and quickly extinguished the fire. Only the bin and the desk directly above it were burnt. A nearby chair was damaged and blackened, and the ceiling of the open plan area was heavily discolored. The purpose of tests 3 and 4 was to study the development of fires which are not controlled by the automatic operation of sprinklers. The automatic sprinkler system was therefore turned off. The fire was started in a plastic waste paper bin partially under a workstation in the open plan area of the building. The smoke detector operated 5 minutes and 45 seconds from ignition. At approximately 7.5 minutes, the glass cracked in the window, and shortly after it fell out. From this point until about 18 minutes after ignition, windows continued to crack and fall out. Finally, the sprinklers were turned on and the fire extinguished. For this test, the steel beams were partially protected with fire protection material, but the composite floor slabs were unprotected. Inspection of the building following the test revealed no damage to the beams or the floor slabs. For test number 4, neither the steel beams nor the composite floor slabs were fire protected. Again, for this test, the automatic sprinkler system was turned off. This fire was started in a waste paper bin in the small office. The door of the office was left about 3/4 open after the fire was started. About 11 minutes after ignition, glass fell from the window between the office and the open plan area. At 20 minutes, the fire was burning at a very low level. After a further 20 minutes, a piece of timber was thrown through the window of the small office, resulting in a small hole, but no significant fire growth. After about 50 minutes, the windows of the small office were smashed. but again this did not result in any increase in fire size. Approximately 6 minutes later, fires were started at 4 places in the open plan area. Eventually, the fire in the open plan area began to grow due to the ventilation created by the smashed windows. About 101 minutes from the original ignition, the fire could be seen entering the small office through the doorway. By 102 minutes, the small office was well alight. And shortly afterwards, the fire rapidly grew in the open plan area. The remaining windows then began to break and fall out as the fire rapidly built in intensity. By about 107 minutes, the fire began to reduce in intensity, and the sprinklers were turned on. There were no signs of distress or damage to the structure of the building during the fire. The structural steel members and the floor slab suffered no permanent damage. The extra light hazard sprinkler system was effective in controlling the developing as well as the well-developed fires in both the open plan and the small office areas. The risk assessment was carried out to compare the estimated risk to life safety in the existing building, a similar building if built now in accordance with the minimum requirements of the building regulations, and the building after the proposed refurbishment. The results of the risk assessment show that the risk to life safety in all of the buildings is low, and that the refurbished building with the fire safety system proposed is the safest of all 3 buildings. In this way, the proposed refurbished building more than adequately satisfies the fire safety objectives of the Building Code of Australia. Reports describing the test program and risk assessment have been prepared. The building authorities in Melbourne have accepted the findings of the tests and the submission by the refurbishers that 140 William Street be refurbished without fire protection, the slab or the structural steel beams that support the slab, and with the current extra light hazard sprinkler system. In the case of this particular building, there has been agreement that unprotected steel, in combination with other components of a fire safety system, can deliver a high level of fire safety. The outcome has been achieved through careful consultation between the authorities, the developers, and independent specialists. It represents a step forward for all concerned, as Australia's high standards of fire safety will continue to be maintained with the further potential of creating considerable cost savings. Meanwhile, the test building is being utilized for further testing, as researchers continue to look for the best solutions to building construction, solutions consistent with life safety and building economies.